Hey folks, this video represents part 2 of our discussion of significant figures. One of the questions that we will ask is what happens when we collect data in the lab with a certain precision and we use those data to do a calculation. We'll look at what happens when we have multiplication and division, what happens when we have addition and subtraction, and what happens when we have a mixed operation. If it's a multiplication or division, what we're going to do is we're going to look at all the significant figures involved in that calculation, and the number of significant figures in our result is going to be equal to the least number of significant figures in our numerical values in our data that we're using to do the calculation. All right, so let's take a look at this calculation here. All right, and 6.38 times 2.0, all right? So if we do this simple multiplication, 6.38 times 2.0 is 12.76. We'll just do that in our calculator. All right, so that's the number we're going to get in our calculator, all right, when we do this calculation. The question is, how do we report it? We got to make sure we report it with the correct number of significant figures that reflects the precision of the data that we're using to do the calculation. So that means what we need to do is we need to look at the number of significant figures of each number in that calculation, all right? And so we're going to take a look at this. In the first number here, we've got 3 sig figs, 6.38. There are 3 non-zero digits. 3 sig figs. In the second one here, we've got a trailing 0, so that counts. It's after the decimal point. So there are 2 sig figs. All right. Now, again, the rule is that the number of sig figs in our answer is going to be equal to the least. So 12.76 is the value we get in our calculator, but the number of sig figs that we should have is going to be the smallest of those two. We have 2 numbers. One has 3 sig figs, one has 2 sig figs, and so our answer is going to have 2. That's the smallest number. So it means our answer is going to be is not going to be 12.76. That's not how we're going to report it. What we're going to do is we're going to say I need 2 sig figs, so I need to round to 2 sig figs. All right. And how am I going to round? 2 sig figs would simply be 2 numbers before the decimal point in this case. So I got to round it up. So it could either be 12, we could either report it as 12 or 13, but we're going to round it to the number that's closest, and 12.76 is closer to 13 than it is to 12. So we're going to report this as 13 with 2 sig figs. Okay? All right, so then that means we need to know how to round. All right, so we just round it to the closest number. And so here are some basic rules for rounding, okay? What we just did, if the digit is more than 5, we round up, all right? So we round it to 13. If it's less, we're going to round down, all right? So if it was 12.24, for example, we would have rounded it to 12. This should make sense. You've probably done rounding before, so you understand the basics of that. When it gets in the situation where it is exactly in the middle, 5, all right, say 12.5, all right, where do we round if it's 12.5? Let me go ahead and write that down so we got that. So let's say we got 12.5 and we need 2 sig figs. So I need to round to have 2 sig figs. Am I going to round it to 12 or am I going to round it to 13? All right. And so the rule that we're going to use here, okay, is if it is odd, then what we're going to do is we're going to round it up. All right. If it's even, we're going to round it. We're going to keep it as is. So for example, in this particular case, it's even. So the 12, in other words, so just to make this clear, I know it's clear as mud, all right? So in this case, this is even. The 2 is even. All right. And again, if it's even, all right, it remains the same. So for 2 sig figs, we're going to round it to 12. Okay. If it was 13.5, so the 3 is odd, we're going to round it to 14. It's kind of tricky. Now, the reality is it's going to be the rare circumstance when you're doing a laboratory calculation where it's going to be exactly 0.5. So this is something you may not have to use very frequently, but that's the basic rule. All right, and there are a couple of examples here in this particular problem that would demonstrate that. All right. So so let's take a look at some specific examples. All right. So here we've got a situation. We've already looked at a situation where we have multiplication. Same rules apply to division. It's the smallest number. Subtraction and addition are a little bit trickier. And in this case, you actually have to look at the specific precision in the calculation. So if I do this calculation where I am adding 6.8 to 11.934, all right? And I do the calculation in my calculator. What I'm going to get is 18.734. All right. Now, how many significant figures should I have? What we need to do is look at the specific precision of each number. All right. How far out does it go beyond the decimal point? So in this case, we're going to note that the first number goes to the tenths, whereas the second number goes to a thousandths. So we're going to use the least precise, in this case, the one that goes out to the fewest number of decimal places, as the determination for the final answer. So the tenths is going to win out here just in terms of the calculation. Am I going to carry it out all the way to the thousandths? Am I going to report it that way? No, because one of the numbers is only precise to the tenths, and that means our final number is only going to be precise to the tenths. So I use that one. This one's a little confusing, so make sure you're asking questions about this if you have any. So this means that this answer is going to be reported as to the tenths only of 18.7. Again, that's because the 6.8 only goes to the tenths, and the 11.934 only goes to the thousandths. So we're going to use the tenths as our determining factor. All right, let's look at a subtraction here. Okay, so in this case, all right, I'm going to note that I have one number which has 4 sig figs. All right, it goes out to the 100ths. The other number has 3 sig figs. It goes out to the thousandths. And again, that means we're going to look at our final answer is only going to go to the 100ths because that's the least precise. 100ths is less precise than thousandths, the fewest numbers after the decimal point. All right, so we do the calculation. What we get when we get our calculator is 10.684. All right, and again, because our precision is limited to 100ths, then we're going to report our answer to 100ths. All right, so we're going to round. In this case, we're going to go 6.8, and then we're going to round the 4 because it's less than 5. We're going to round it to 10.68. So our result is going to be 10.68. All right, so make sure that you understand the difference between multiplication and division and addition and subtraction. The rules are slightly different. Best way to go about doing this is to really think about the precision, but also just do a bunch of examples so that you're comfortable with this. All right, so again, continue to ask questions if you have any about that. All right, let's do one that's a little bit more complicated. So here's a complex number, mixed operation. So you'll notice that we've got a quantity here that's an addition, and we've got then multiplication and division involved in this. So we've got both types of operations. And the way we're going to deal with this is we're going to figure out the precision of each particular operation. All right, so the first thing we do is we're going to go ahead and we're going to calculate the value within the quantity first, the addition quantity. And when we do that, we get 7.996. All right, so we do that first. All right, so that's going to be that, and that we're going to multiply that by this 6.950 and then divide by this. So once I've done the addition, what's left over is multiplication. So once I figure out the number of sig figs in my answer in the addition, then I'm going to use that in the multiplication. So how many sig figs am I going to have here in my addition problem? All right. So again, when we're dealing with addition, we're looking at the precision after the decimal point. We're going to note that the first number here goes out to 1/1000ths, and the second number also goes out to 1/1000. So that's easy. They're both out to 1/1000ths. That means the result of that addition is going to have precision out to 1/1000ths. Okay, and so we're going to have 7.996. That's precision. All right, so it's got 4 sig figs. All right, so now I've got 4 sig figs, and I'm taking 6.950 times 10 to the 4th. So when I've got scientific notation, when I've got exponents, we're just looking at the digit. We're not looking at the exponent. This is 6.950. That's going to have 4 sig figs. And we'll be reviewing scientific notations and exponents in our next slide. But so we'll come back to that. So 7.996, the first operation is 4 sig figs. Second operation is 4 sig figs. And that's divided by 5 sig figs. All right. So once we've done the addition, now we're doing multiplication and division. And the rules for multiplication and division are that the number of sig figs in our final answer is determined by the least number of sig figs in our calculation. So we do the calculation here, and calculator is going to give us a value of 9.7869 times 10 to the 4th. Again, how many sig figs are we going to have? We've got 4 sig figs times 4 sig figs divided by 5 sig figs. So our answer is going to have 4 sig figs. And so our final answer then is going to be, with 4 sig figs, 9.78. All right. So there's 3 sig figs. That means I'm going to have to round, and at 69, I'm going to round that to 787. So that is 4 sig figs in our final answer. All right? Okay. It's going to take a lot of practice for you to get used to this, but certainly ask questions. Now we're going to talk about a little bit about logarithms and exponents. We already talked a little bit about exponents and scientific notation, but in this situation, for example, if I'm taking a logarithm, whether it's a natural log or a base 10 log, it doesn't really matter what we're talking about here. In the case of taking a log, the number of sig figs in our final answer is going to be, since I've got 3 sig figs in the log, and so in our final answer, we're going to have 3 sig figs after the decimal point. All right, so that's it. So 3 sig figs, all right, is going to be converted to 3 sig figs after the decimal point. Notice that. That number has 4 sig figs, but it's the number after the decimal point that were included in that. All right, so that's the deal with logarithms. And exponents, we got, in this case, an exponent of 3.24. The number of sig figs in our answer is the number of sig figs after the decimal point here in that. So I've got 2 digits, 2 sig figs after the decimal point. So my answer is going to be 1.7 with 2 sig figs. Again, this might be confusing, but the 3 here in this number is actually reflected in the case of 10 to the third to the power. All right, so that's in the power. The numbers after the decimal point then determine the number of sig figs in our answer, 1.7. All right, I hope that's clear. Certainly, this has been a quick review of sig figs. Make sure you do lots of problems and examples so you can figure out exactly and get used to it. It's really important when we're reporting data. It's really important to understand precision of data and the results that we get from that. And this is something you're going to be doing in the lab, and if you're working in the lab in the future, it's also going to be really, really important. So make sure that you're working on examples, and if you have any questions, let me know.